Hello everyone, I'm going to show you guys how to do the beam vibration analysis both with the no dampening and the 5% dampening. This is for the 1 meter cantilever beam with a cross-section area of 5 centimeters by 10 centimeters. We are going to be using Ansys for this, so let's get started. First of all, go to the workbench. There's a free student version of this. If you just look up Ansys student, you should be able to find it, no problem. The first thing we're going to be doing is doing some CADing. So just wait up for this thing to load. Give it a couple minutes. All right, now we have Workbench. What we're gonna do is go to Modal and drag in a new project. We're gonna go to Engineering Data. And we're going to go to Engineering Data Sources, Ansys, Grad Materials, and as specified by our project, we're going to be using aluminum 6061, which is going to be right here, aluminum alloy, route 6061. I'm going to click on the plus. Now we can close this. Let me double check, make sure that this is actually here, right here. I like to delete this just so that it doesn't make any confusion. But right here we have our aluminum alloy. Now we're going to go to the project and start with the geometry. Right click on this and new design model geometry. Wait for this to launch. These programs are very powerful, so they usually take a really long time to load. Now that we are on our CADing, we're going to click on the Z-axis here and make sure that we are able to see our XY plane. We're going to create, or actually here, sketching, rectangle, just like straight up, just do it here. I'm going to zoom in by pressing Control and then scroll wheel, dimensions. We have the general dimensions right here. This is going to be our base, which is 0.1 meters or 10 centimeters. And then our height, which is going to be 0.05 or 5 centimeters. I'm going to zoom in so that I have a better view of this. Let's make it the other way around, actually. 0.1, 0.05, just to make it look nicer. Over here, we are going to click all. Oops. Right, click all with the Control key. Going to Concepts. Create, we're going to extrude. This is going to be by 1 meter. Apply. And right here we have our beam. In this scenario, all we really want to do is just, if we click here on the extrusion, go to concepts, or actually, after we do this, if we click generate, yeah, there we go. Now we have our piece. We are basically done on the CADing software, so we can exit out. Not on model. I like to update every time I do anything, so I'll just right click updates, give it a couple seconds. Give it a couple seconds. perfect. We're gonna double click on our model. And we will be able to do all the analysis on this next page, so it should not be a problem. Here it is, our page is loading. Again, we can view the axis on the x-axis here. And now what we're going to want to do is, first we're going to make sure that the material we're using right now is the proper material that we're supposed to be using. So create a material assignment. We're going to click here on body, click on this, apply. And now all this material is made of aluminum. Now we're going to go to mesh, insert, sizing. We're going to click on the corners, and I am going to click on, where is this? Give me 1 second. There it is. I'm going to click all 4 corners. I'm going to click apply. And then over here, we're going to change the type to number of divisions. And we're going to be doing the first one, which is 5 elements. I am going to change this to number of divisions 5. And then right click on the edge sizing and generate mesh. We should be able to see here that it is indeed divided into 5 sections. Perfect. What we're gonna do here then is on solutions. We're gonna right click on solutions, insert deformation total, and then insert, actually not this. Once we have done this, and now we're going to click on solve. It's going to take a couple seconds, and then we can see underneath here it's starting to solve the solution, to give us the solution. Actually, I forgot to do something. I forgot to do something very important. Yeah, I forgot to do something very important, which was, where is it? Oh, here it is. We're gonna go to model, right click, insert, fixed support. And it's gonna ask us to click on the geometry. We're going to click on the side. It's kind of like analyzing this beam as if we were stuck to, like, attached to a wall. We're going to click on face, click this face, apply. And with that, now we should be able to get a better analysis, because if you see right here, this is basically the beam just doing whatever. But if we now solve, we're going to be seeing that there you go. Now the beam is going to be oscillating around this attachment. And if we want to be able to see like an animation for it, we can click here and play. And we can see the movement of the beam as it goes. Let's stop this. This is, because it's undamped, this is basically just gonna go forever. We could also just do this for 2 seconds. Make it a little more faster. There we go. Nice and clean. This is going to be part of our answers right here, which is, this is the mode and this is the frequency. Remember, this is for 5 divisions. If we want to change the divisions, we just go to edge sizing. We're gonna change this one to 20. We're supposed to do 3 divisions, which is 5, 10, and 20. I'm just gonna skip the 10 and just do the 20 straight up. Right click on mesh, generate mesh. Give it a second. And now we can see it's divided into 20. Now I'll go back to total deformation and solve. Again, it's going to take a little bit. But we already have our solution here. Again, this is our mode and a nice clean video that we can use if we want to. And this should be our answers right now. Now, this is for this no dampening. If you want to set this to be damped, now we're gonna wanna go to modal, right click, insert. Oh, I'm sorry. We're going to go to modal, and where it says in analysis settings, we're going to left click it, and right here it says damped. We're gonna change this to yes. Damping controls. Constant structural damping, we're going to change it to 0.05, which is the 5% that it is asking us to do. And now, if we click solve, we are going to go to total deformation. And if we set this to, let's say 20 cycles, let's do 30 cycles, why not? And set this over 4 seconds at 100 frames. We should be able to see that slowly I don't know what's happening here. 10 seconds. I don't know why it's bouncing though. Oh. I don't understand what's happening here. Yeah, this should be it. I don't understand what's happening. There it is. Now we can see that with the damped, slowly but surely, the beam is like slowing down. You can see it right about there. You can see how it starts very, very violently and then like slowly starts dampening. And then again, here is going to be our answers for our chart. And this is basically it. There's another part of this project, which you're supposed to do an analysis on this beam when it's squared. So all you want to really have to do is just exit out of here, go back to geometry, and then edit geometry with this in designer mode. And then square beam by variation analysis, and this is a 5x5. So all you really want to do is on my sketch, just change this number to 0.05, generates, and there you go. That's all you really have to do. We can close this and go back to our updates. Give it a couple seconds while this finishes. There you go. Now we should have our everything crashed. Amazing, I love that. I love it when it does that. Come on. Right, let's see if it's gonna crash again. Awesome. Here is our square beam. Again, we just lock into here. I believe our fixed support is still in the same location. It is. And now we really have to do is just click on solve. Let the program do its thing. Click on total deformation. And there, let's do one. Let's do 100 cycles, just see what happens. I guess nothing happens. 10 cycles. But anyway, this is basically the project. You can see, if you want to see the directional, so the X and Y deformations, all you really have to do is just right click, insert deformation, and then directional. Again, just click on solve. When this is ready, you should be able to see how it bends. I guess it's slightly different. But anyway, this is how you do it. I hope this tutorial helped people, and see you guys around.